In this lesson, we're going to be taking a look at a property in algebra that is very, very much central to all of algebra, and that is the distributive property. You're going to need to understand the distributive property to do a lot of what we need to do in algebra. We're going to use it with simple expressions where you don't actually need to use the distributive property, but it is one way of solving these numerical expressions. But when we get to algebraic expressions, when we get to variables, which we are going to be seeing, not only is that going to be something that's necessary to use the distributive property in algebra, but also it's going to feel a little complicated. Okay, so just stick with me. This is a short lesson about one very important thing, the distributive property. Let's get started. We're going to start by writing out the distributive property in mathematical language here so you understand what it is. So the distributive property applies really to multiplication and addition. So you're multiplying two numbers that are being added together, okay? So this is what it looks like. For all real numbers, A, B, and C, because we have to have at least three numbers to use the distributive property, you're going to see that it works with more than three as well. This is what the distributive property does. A times B plus C equals A times B plus A times C. Notice I'm multiplying the B and the C in parentheses. B plus C are being added together. I'm multiplying them both by A times B plus A times C. It's like I'm distributing the A to the B and the C. All right, what about this situation? What about A times B minus C? What's going to happen there? Well, that's going to equal AB minus AC. Okay, so I'm just introducing something that's going to create some problems for people. And that is when we use the distributive property, you have to keep track of negatives. Hey, what if A is a negative number? And then you're multiplying negative A times B plus negative A times C. Hey, what if A is a negative and it's minus C in the parentheses there? Then it's going to be negative A times B minus a negative A times C. So you have a minus, so we have a plus. But then, wait, what if C is actually a negative number when you plug it in to evaluate it? And A is a negative number. Then you have a negative, negative, negative. So do you see, you're going to have to write these out step by step to keep track, especially when you have negatives involved, and especially when you have the minus sign in the parentheses involved. Okay, so that's just an important point I'm going to make right away. Let's take a look at some examples of how this plays out in the real world. 5 times 2 plus 1. You could easily solve this problem by adding together 2 and 1, right? 2 plus 1 is 3 times 5. So we did what was in parentheses first, and then multiplied by 5, we get 15. Or we could use the distributive property, which allows us to do the multiplication first, but only if we multiply by every number in the parentheses. So equals 5 times 2 plus 5 times 1. So that's going to equal 10 plus 5 equals 15. See how I got the same thing both ways there? What about 5 times 2 minus 1? In that case, I have 5 times 1 is 5, right? Well, let's just see how that works with the distributive property. 5 times 2 minus 5 times 1. I have to do the multiplications first. So 5 times 2 is 10 minus 5 equals 5. And that's exactly what we would have gotten if we would have done 2 minus 1 first. Now, again, we're going to be seeing some problems that you can work by just using order of operations, but you can't work problems with variables by just using order of operations. So when we get to example 3 and 4, you're going to see some problems you actually need to use a distributive property to solve. Let's take a look at example 1a. 6 times 4, I'm just going to try to write this out here to be as clear as possible, plus 8. Okay, so if I was going to use a distributive property to solve, I would say that this is equal to 6 times 4 plus 6 times 8. I have to distribute the 6 to both things. Hey, take a look in your textbooks on page 80. Do you see how they demonstrate this for you by showing the little arrow pointing from the 6 to the 4 and from the 6 to the 8? That's an excellent way to visualize what's happening with the distributive property. You're multiplying the 6 by both things. So I would recommend that you write that out as you work these problems, that you actually write out the initial problem and then show the little distribution arrows. So you're multiplying by the 4, you're multiplying by the 8. Okay? 6 times 4 is 24. 6 times 8 is 48. So we're going to have 24 plus 48. This is going to equal, what is that, 72? And let's just see if this would have worked out the same way before. Well, if I did 4 plus 8 first, it would have been 12. 6 times 12 is 72. So we got the exact same thing either way. We're going to skip B for right now, and we're going to go on to example. You can look at B if you want. You'll understand it immediately. We're going to go on to example 2, A and B. Hey, what if I have a negative sign out in front of something that's being added together, in front of parentheses for something that's being added together, 9 plus 4. I've said this before. It's like the negative sign distributes to both things in parentheses, because it's like we're using -1 times 9 plus 4 when we have a negative sign out front. We just don't write the 1 because we don't have to, because of the identity property. So this is going to equal -9 minus 4, or -9 plus a -4. Okay, so that's just an important point, an important thing that you're going to have to get used to. Anytime you see a negative out in front of something being added, both things inside become negative because the negative distributes through the distributive property. What about -9 times -6 minus 3? Oh boy, that's a lot of negatives to keep track of here. Well, we're going to make sure we write this out in a very step-by-step way so we keep track of everything. So I'm going to say that this equals -9 times -6, and then minus, because I need to use a minus sign here, and it's going to be 3 times -9, or -9 times 3. Either way, I'm going to write minus -9 times 3. And we'll just remember we have to do the multiplications first. So the multiplications are -9 times -6. That's going to equal 54. And then 3 times -9 is my other multiplication. Also, it's not a plus sign, which is a minus sign in between. You have to keep track of your minuses. It's going to be a minus a -27, because -9 times 3 is 27. So this becomes 54 plus 27. 54 plus 27, which is 81. Okay, that's example 2. Now we're getting into the good ones. 3A. So we're looking at example 3, and I'm just going to use the same notation here, A. Okay, and here we have -4 on the outside, and then x plus 7 on the inside. I have to distribute the -4 to each term in parentheses. So this is going to end up being -4 times x plus -4 times 7. Well, the good news for this one is that the -4 times x doesn't need to be simplified further. We don't know what x is, so we just leave it as a variable. But we do need to simplify -4 times 7, because that just becomes -28. So it's going to be plus -28 or minus 28. And that's how you would solve that one. Make sure you just keep your negatives straight. Notice it's -4 times each term, not just 4. Let's take a look at letter B. Here, the only difference here is that for some reason, this is sort of a backwards distribution, because 6 was put at the end. 5 minus x times 6. And yes, we could distribute backwards when we have something on the outside of parentheses after. That's 6. To multiply 5 minus x, you have to multiply both terms. So 6 times 5, I'm just going to write out each part of this. 6 times 5, there we go, minus 6 times x. Okay, and let's see. When I do this, it's going to be 30 minus 6x would be a valid way to write this. Usually we write it with the variable term first, though. So -6x plus 30 would maybe be a better way to write this. Either way works there. Not a big deal. Now for the really hard ones. Example 4. We're going to be dealing only with variables and maybe one coefficient here, okay? So what about this one where I have mn outside of the parentheses, and then mx plus ny plus 2p. Two things going on here. First of all, I'm only using variables. And secondly, I have three terms in my parentheses. What do? The same thing we've been doing. This is going to equal mn times mx. Okay, so using that, I'm not gonna use the time symbol. I'm just gonna put it in parentheses there because I don't want our x's to get confused. Plus mn times ny. Okay, I just want to make sure I get the right terms here. Plus mn times 2p. All right, now when I'm multiplying these together, I remember the exponent rules. M times m is actually m squared. So I'm going to have m squared in the first term times n times x, right? Because I just have one n and one x and they're all being multiplied together. So it's basically saying m times n times x, but I just put m squared together there. Plus, in my next term, I have n times n. So it's going to be m times n squared, m times n times y, okay? Plus, and then the last term, we always put coefficients in the front. So it's going to be 2 times m NP. And that is the correct way to simplify that. Let's take a look at one more of these, and then we'll be finished. And our last one, negative xy times, in parentheses, y squared, so y times y there, minus x squared z. All right, let's go ahead and do this one. This one's complicated. So it's going to be negative xy times the first term, and then negative xy times the second term. Well, negative xy times y squared, you can see how that's going to simplify there. And then minus, I have to keep the minus sign. And here we have to do some negative sign management. Minus xy, negative xy times x squared z. Okay, now I just need to simplify by putting like terms together. It's going to be negative x, let's see, I have y times y, or y times y squared is just y cubed, according to my exponent rules there. Negative xy cubed, and then I have minus a negative, so that's going to turn into plus, minus the opposite of xy times x squared z, so it's going to be x to the third y z, plus x to the third yz. All right, that's how you use the distributive property. You're going to go ahead and do that for problems, apply that when it comes up on problems 1 through 30 in the practice section for next time.